trying to, the first though, in data cleaning, the first thing you should do is to clean it column by column. And what do? Sort the column to find out if there are outliers. It will give you an overview. And in doing that, just select the column, go to data, and click on the sort cases. What you want to sort is a household size. And then you click OK. Now, as you have done that, you will see that you now see that there are a lot of missing values. You see, if you had not done that, you will realize that these are missing. And if you run with it, it will give you a wrong analysis. Now, go also to this point. You will also discover that household 45 and household 14 has numbers that appears not valid, 99 or 999. So what do you do in this case? There are simple things you can do, and that is to use the mean value to replace the missing value. First is that you will go to the variable view and set those numbers 99999 as missing value, so that once you give the command, it will identify it and will treat it as the same. So now that we have done that, to do this, you go to transform, and in transform you get to replace missing values, and then you select what you want to replace, and there are options here. Method is series mean. There are these other options, but of course it depends on the what you want to do, and you click OK. Once you do that, it has replaced column that it will work with and all that. So if you see this, it will tell you that in these variables, rather in these data sets, that the number of replaced missing variables or missing values are 746. If you have done this, it simply means at this point that the numbers are now equal, and now the missing numbers are replaced with the mean values of what you are working with and all that. So in this case, if you run descriptive statistics, you will see that there is no missing number anymore. There is no missing number. All the numbers are valid. So that's how to do data. To run the descriptive statistics, the data is loaded. You go to Analyze, click on Descriptive Statistics, and click on Descriptive. Move all the data one after the other. You can do it, double click, whichever, or you can select all and move. Then you click Option, and Option, this is mean. You select what you want: the mean, the standard deviation, the minimum, the maximum, if you like, the variance, the range, and anything you want, depending on the kind of research you want to do. And you click what? OK. And you interpret your result. So it is telling you the descriptive statistics, telling you the number, the minimum, the maximum, the mean, the standard deviation, as you have selected in your option menu. Right. To run your chart in SPSS, for instance, we want to run to build a chart for the member age. Remember, member age is a scale variable, and in this case, we can use histogram. So how do you go about that? You go to your scale, click on chart builder and then locate histogram. Now once you click histogram, any of the histogram you want, you drag it there. Let's use simple histogram. Drag it there and then locate the variable you want to build, which is the member age. Click it, drag it to the x axis and click OK. So our histogram is there for you. With it you can interpret it, and as the case may be. Now if we go again, we can also do the same for one of the nominal variables. In this case, we can build the graph for gender. Gender is a nominal variable. So you do the same thing. Go to graph, chart builder, and then use bar chart. So when you look at bar chart, drag any of the one you want to the place, and then click on the variable itself, which is the gender. Drag it to X and then click OK. So your bar chart is built. You can see that relatively male are more in number by virtue of this count. And then lastly, we can as well create our pie chart on the nominal variable. In this case, we can use member age. Yes, member age to build our pie chart, or as the case may be. All right. Now, or we can use the household size. Sorry. Okay. Let's do the last one, which is the pie chart. And pie chart here, we can do that with household size, which are different sizes of a household, as the case may be. And then in doing that, we follow suit, go to chart builder, click on pie chart, drag it, and click on the size. Take the size to this spot and click OK. So our chart is now located to you that household size 4 has this household size 4, 5 has that, and so on. So this is how you build your to compare two groups. In this case, the gender, which is the male and the female, we want to carry out the t-test of these groups. And then what do? We go to analyze, click compare means, and then click on what? Independent what? Sample t-test. In this case, the variable we want to analyze is the income index. You send it there, and the factors, the variable we want to compare, the groups rather we want to compare. In this case, the variable we want to compare is the index, and then the group we want to compare is the gender. Then you define it. If it is not defined, group 1 is male, group 2 is female. You click OK, and this is your t-test. You have group statistics, you have this, but this independent t-test is the major test required in this case. You could see the F statistics to be 7.086. You see, the probability here is greater than 0.5. So in any case, however you want to look it from, we can categorically state that the p-value is less than or equal to 5, either on the basis of equal assumed or equal, not are assumed, as the case may be. So with this, we can conclude that there is a statistically significant differences between the male and the female income. To run the ANOVA, which is comparative analysis among 3 or more groups, we use ANOVA. In this case, we have education level, which is 1, 1, 1, 2, and 3, representing secondary education, diploma, and university. Right. To do this, we go to analyze. Compare means we move to one-way ANOVA. So what is the dependent variable that we want to analyze? It is the monthly income. What is the factor or independent variable? That is education levels, and so on. We click OK and conduct our analysis. So in this case, this is what we have. You look at this table, you see the sum of squares, you see the degree of freedom, you see the mean square, you see the F statistics, and you see the significance level. Among all this is very important. If once this is less than or less than 0.05, it means that it is significant. And what does that mean? We're trying to say that the probability that the observed differences happens by chance is less than 0.001. In other words, we can say categorically that the difference that occur doesn't happen by chance. It is significant, and so on and so forth. If you look at the F statistics, you also see it is big. You look at the difference between the groups and the difference within the groups. You will see that the difference between the groups is about 12 billion, but the difference within the group is about 310, telling us that the difference within the group is far less than the difference between the groups. We are moving into a deeper lens, trying to see how far we can conduct deeper analysis using SPSS, where we'll probably be working on either comparative analysis, and in subsequently we could do regression. And see you in our subsequent model. If you have not subscribed to this channel, please do, so that you'll be updated whenever we release a new video.